Okay, so in this lesson, we're going to really develop our notion of the integral, and we're really going to think hard about what the math we're doing means here. So what we want to do is put this in the context of the derivative. So a derivative told us certain things about a function, namely how it's changing, right? And an integral will also tell us a certain thing about the function, again, related to how it is changing. Let's make that a little bit more specific though, eh? So our derivative has been the rate of change at a particular point of a function, right? So the derivative of position gives us speed, for example, and that's how we've interpreted, right? So in our math notation, we'd say that f prime of x is the rate of change of f of x, right? So that's the derivative, that's our familiar one. The integral is less familiar, right? This is the new one. So still studying calculus, so we're still looking at change, right? Remember, we're studying the mathematics of change here. But this time the integral is the sum of total changes on an interval. So I'm going to write down this in mathematical notation. Here's where you want to be very careful that you copy the notation down correctly, because this is what we're trying to learn here. So the integral from a to b of f prime of x, I'm going to say dx, is the total change of f of x on a to b. So if we could add up all the little changes of a function all together on a certain interval, that is the integral. And that's what we studied in the last lesson with the area under graphs, right? So let's put this into play a little bit. So to do this, we're going to kind of put this all together. And again, we're doing the work of interpretation and figuring out what a question is asking us for. The calculator this time is going to do the integrals for us. The calculator button for this is math, and then 9. fn_int is the name of the function. So we'll see what that looks like here in a second. You will do best with this lesson if you get out your calculator now and follow along with me and make sure you can reproduce my results. So go ahead and grab that if you need it now. Pause the video. Okay, so I have my calculator here, and we've seen this problem before. This was on a previous mastery. It was kind of a rate in, rate out type of problem where penguins were born and penguins were dying. We're just going to worry about the penguins being born and not think about the dying penguins this time. And then notice in the text it says birth rate is b of t. So this function is essentially already a derivative. It's the rate at which the population is growing, right? So we have 3 questions here. Not all of them are going to use integrals here. So the challenge here is to figure out which one is which. And I'm going to show you a little trick here. So we're going to use this function 3 times. I don't want to type it in 3 times. So before I even worry about that math 9, the integral button, I'm going to type this into my graph, or I'm going to type it into y equals. So I'm going to hit y equals, and then I'm going to type in the function just exactly how it appears, except for with an x for a t, right? So there's my y equals. And now, as I go to answer these questions, so I want the total number of penguins born over the first 10 years. So let's write the integral first. So that integral would be the integral from 0 to 10 of b of t dt, right? So this is the sum total of all the penguins born over the first 10 years is what this integral represents. And then I can go ahead and solve it on my calculator using that integral button. Remember, b of t is my y1, so what this could look like is I could go math 9, and then my bounds are from 0 to 10, the first 10 years. And then instead of retyping my whole b of t, I'm going to hit the variables button, vars, and go over to y variables, hit function, and then I get a list. So I can just stick in that y1. Make sure you rewind if you didn't see that. And then with respect to x, and then hit enter. And there's my solution. So about 13,702 penguins, if I round, how one would expect, right? So the interpretation is on the first 10 years, from year 0 to year 10, 13,702 penguins are born. So easier enough, right? That was an easy question. Now, how many penguins are there total on the island after 10 years? Well, here we have to go back to the text a little bit. So notice there's 100,000 penguins on the island at time 0. So here we would say, well, 100,000 penguins. This is called an initial condition, by the way, the starting value, plus the integral from 0 to 10 dt dt. And we already got that number, right? So roughly 113,702 penguins. Okay, so those are very common integral type problems that we'll see. Find a total change or find a value after a certain number of years in this case. So we take the initial condition and we add the total change. And then my last question is the birth rate increasing or decreasing at time 10? So notice this isn't asking us for a total change, right? This isn't asking us for a sum anymore. This is really just asking us about how the rate is changing, right? So what that tells us is I don't care about the integral for this question. I care about b prime of 10, right? I care about the derivative because the derivative is going to tell us how this is changing. So as I go back to my calculator now, remember I saved that function, and here I can use my old friend, the Math 8 button. So again, d dx, and then variables, y vars, right? And I can just plug in that function, y1. And my x this time is 10, right? Because that's the time I'm interested in. And it spits out a positive value, 109.327. So my birth rate, the interpretation here is my birth rate is increasing at 109 penguins per year. Okay? So that's a little bit of work with integrals and derivative mixed together, and really we're starting to see all the different things we can figure out given a function using these two tools. So on the bottom, I've given you the little shortcuts, little examples of how these look on your calculator. But really, this is just an exercise in figuring out what the question is asking you and figuring out how to tell your calculator how to give it to you.